Okay, hello everyone. Welcome to Extra Touch Academy, where you learn, grow, and become. So please do well to share this channel, like, comment, and please, I need your comments so that I will know where the topic to uh, make and also to help to make you to become better in your mathematics. So we are going to be treating, in our last video we discussed about sort, where we explain how to add, subtract, and multiply in sort. So we have different sections here. So we'll start with this, division in sort. Like I said, is a very sensitive part in this sort. So let us go to the question there. We have number one, we have simplify root 35 over root 5. So the idea of division in sort, when we get to this, you understand better, is to make sure that the denominator is a rational number, that there is no square root at the denominator. So you can see I have roots and root here. I can combine two of them. This is like 35 over 5 is equals to root 35 divided by 5 is 7. And 7 is the answer. That is root 7 is the answer. Because 7 doesn't have any perfect square there. Number 2, we have root 17 over 4. So I can split them out because 4 cannot go into 17. This root 17 over 4 means 17 over root 4. Still the same thing. So is equal to root 17 over 4 is a perfect square. Square root of 4 is 2. So you discover that from here, there is no square root again. The same thing with here. This is like over 1. So in a scenario where the number can divide the number up, and the number here is a perfect square, it is very easy. But when you get to a point that the number at the denominator cannot divide the number up, that is where we are going to be dealing with. We call it rationalization of sort. To rationalize means to make the denominator to be a whole number without that square root. So we have rationalized the following. Let's start with that one here. So we have 1 over root 3 is equal to 1 over root 3 first. The rule is that you are going to multiply the numerator and denominator with whatever that is down here. And from here you can see we have root 3. So I'll multiply the numerator and the denominator with root 3. 1 times root 3 is root 3 over, from in our last video we said that when the numbers are the same, you can see we have 3 here, 3 here. So I'll pick 3 and that is the answer. So we'll go to B. We have 10 root 2 over root 5 is equal to 10 root 2 over root 5 times the number at the denominator is root 5. So we have times root 5 over root 5 is equal to, let's be careful here. We have 10 here outside. We have invisible 1. 10 times 1 is 10. Root 2 times 5 is 10. All over root 5 times root 5 is 5 because they are the same number inside. 5 can go into the 10 outside, not the 1 inside, because this one doesn't have square root again. So 5 here is 1, 5 here is 2. So our answer is 2 root 10. 2 root 10. We'll go to C part. We have 7 root 5 over root 7 is equal to 7 root 5 over root 7 times root 7 over root 7. Make sure you multiply the numerator and denominator with whatever that is at the denominator here. So 7 times invisible 1 here is 7 root. 5 times 3 is 35. All over 7 times 7 is 7 because they have the same number inside the root. 7 is here, it will cancel out. So our answer is root 35. If there's a perfect square inside here, it means that you have to simplify further. But we don't have any perfect square in 35. So we go to D. We have 6 over root 3 is equal to 6 over root 3 times root 3 over root 3. 6 times root 3 is 6 root 3 over root 3 times root 3 is 3. Remember, they have the same number inside. So I have 3 here is 1, 3 here is 2. So the answer is 2 root 3. So the idea of to rationalize a surd means that you are trying to make sure that there is no square root at the denominator. And how do you achieve that? By multiplying the numerator and denominator by what is down here. You can see number 1a, this a here, we multiply both this and this with root 3 and root 3. For this one, we multiply with root 5 and root 5. For this one, we multiply with 7 with root 7. Can you see that now? For this one, the same thing is applicable there. But in a case that we have more than one term at the denominator, that is what is called conjugate. For example, we have a surd at this denominator. If this kind of number or surd is at the denominator, we have 2 plus root 3. You use the conjugate to multiply the numerator and denominator. But here you can see we have only one term at the denominator here. So we are going to do 2 minus. The only difference between this is that just put minus, the opposite of this sign. So the opposite of plus is minus. Then, for you to multiply, just pick the first number here, square it, minus, you square this one here. Because when you square this, square and square root will cancel out. Look at this one. You can see I have 2 minus root 3. The conjugate is 2 plus root 3. So if I have, in a case, let's say I have root A plus root B, like here. From here you can see I have A plus root B. The conjugate is A minus. Just put minus, the opposite sign of that. Then pick the first term, square it, minus the second term. You square the second term also. This is idea of difference of 2 squared. So we are going to use these 4 examples to illustrate how to go about this. So let's go to the question here. So we have number 1 here. We have simplify 1 plus root 2 all over 2 minus root 3 times. So what you are going to do, you go down here. What is the conjugate of 2 minus root 3? Is 2 plus root 3. So I have 2 plus root 3 over 2 plus root 3. You will do it both on the numerator and denominator. Is equal to, we are going to use this one to multiply everything here and also use root 2 to multiply everything here. So 1 times 2 is 2 plus 1 times root 3 is root 3. Root 2 times 2 is, let me bring it down here so that, okay, 1 times 2 is 2, plus 1 times root 3 is root 3, plus root 2 times 2 is 2 root 2, plus root 2 times 3 is 2 times 3 is root 6, all over. Then the idea of what we did here, you can see that when conjugate, when a surd is being multiplied by its conjugate, you pick the first number here and square it, put minus, pick the second term here and also square it. That is the idea of what we just explained here. So let us try to, so we have 2 plus root 3 plus 2 root 2 plus root 6 all over. 2 square is 4. This square will cancel this square root. We have minus 3 is equals to 2 plus root 3 plus 2 root 2 plus root 6 all over 1, which is equal to 2 plus root 3 plus 2 root 2 plus root 6. So this is the answer. Anything divided by 1 is that. You can see we don't have anything that is like them there. 2 is alone, root 3 is alone, 2 root 2 is alone, and root 6 is alone. So this should be our answer. Then number 2. We have rationalized the expression. We have 7 minus root 3 all over 13 minus root 3 times the conjugate of this. We use it to multiply the numerator and denominator. The conjugate of 13 minus root 3 is 13 plus. So we have 13 plus root 3 over 13 plus root 3 is equal to 7 times 13 first. So 7 times 3 is 21. 7 times 1 is 7 plus 2 is 9. So we have 91. That is 7 times 3 is 21. You write 2 and carry 1. 7 times 1 is 7 plus 2, 91. That is how we got 91. Then we have 7 times root 3 is plus 7 root 3. We are done with this 7. Minus root 3 times 13 is minus 13 root 3. There is minus here. Root 3 times root 3 is 3 from what we stated before. Then, when you are multiplying a surd by its conjugate, pick the first term, which is 13 here, square it, minus, pick the second term, which is root 13, square it. Minus must be there. Minus must be between them. So, let's bring the numbers together. We have 91 minus 3 plus 7 root 3 minus 13 root 3 all over 13 square is 169 minus square will cancel square root 3. So 91 minus 3 should give us 88. Then 7 minus 13. Remember, these are like surds. So we have 7 minus 13 all in root 3. All over 169 minus 3 is 166 is equal to 88. 7 minus 13 should give you minus 6. So we have minus 6 root 3 all over 166. You can leave your answer like this, but there's a number that can go into this, this, and this, which is 2. 2 going to 88 is 44. 2 going to 6 is 3. 2 going to this is 83. So we have 44 minus 3 root 3 all over 83. And this should be the solution of that B number 2 part. So let's go to the number 3 there. So we have number 3. We have, without using tables, find the value of 1 over root 11 minus 2 minus 1 over root 11 plus 2. Let's use the idea of LCM. So bracket root 11 minus 2 bracket root 11 plus 2. So just, you can see they are different. They are conjugate of themselves. So let's use this method so that we can be able to multiply. So this LCM here divided by this and this will cancel. We are left with root 11 plus 2 because anything multiplied by 1 will still give you the same thing. So we have minus, let me put it in a bracket, this LCM divided by this will cancel this. We are left with this. So we have root 11 minus 2. So let's try to open the bracket. We have root 11 plus 2. Minus is affecting 2 of them. Minus root 11. Minus times minus is plus 2 all over. Remember, these are conjugates of themselves. This surd is a conjugate of this. Can you see now? So how do we do that? Pick the first term, square it, minus pick the second term, square it. So we have, let's bring this together. We have 2 plus 2 plus root 11 minus root 11 all over. Square will cancel square root. We have 11 minus 2 square is 4. So we have 2 plus 2 is 4 plus root 11 will cancel minus root 11. All over 11 minus 4 should give you 7. So 4 over 7 is the answer. Okay, so let's go to number 4 question before we conclude. We have simplify 3 minus 2 root 2 over 3 plus 2 root 2. So don't make the mistake of cancelling this. They are not the same. This one has minus, this one has plus. So we have times the conjugate of 3 plus 2 root 2 is 3 minus 2 root 2 over 3 minus 2 root 2. So going by this, let's try to multiply. 3 times 3 is 9. 3 times minus 2 is minus 6 root 2. Minus 2 times 3 is minus 6 root 2. Minus 2 times minus 2 is plus 4. Times root 2 times root 2 is 2 because we have the same number inside. All over, using the idea of conjugate, difference of two squares. So we have, pick the first term, 3 all square minus the second term is 2 root 2 all square. So let us try to simplify this. We have 9 minus 6 is minus 12 root 2 plus 4 times 2 is 8 all over 3 square is 9. This square is affecting both these two outside and this square root. So 2 square here is 4 times this square will cancel this square root. So we have 2 is equal to 9 plus 8 minus 12 root 2 all over 9 minus 8 is equal to 9 plus 8 is 17 minus 12 root 2 all over 1. So our answer is 17 minus 12 root 2. And that is all in this topic. So we have been able to explain how to use the conjugate to solve our question that involve this kind of solved question. So it's something that you have to get used to. From time to time, the more you solve the question, the more you get used to it. Just a quick one before we stop. I purposely left this question here. You can see we didn't attempt this number 2 here. I wanted to explain how to divide before we go to this. So let's go to this number 2 question here. We have 2 root 3 minus 6 over root 3 times root 3 over root 3. Remember, plus 3 over root 27 times root 27 over root 27. So we have 2 root 3 minus 6 times root 3 is 6 root 3 all over root 3 times root 3 should give you 3 because the numbers are the same. Plus 3 root 27 over root 27 times root 27 is 27. So 3 here is 1, 3 here is 2, 3 here is 1, 3 here is 9. So we are left with 2 root 3 minus 2 root 3 plus root 27 over 9. 2 root 3 minus 2 root 3 is 0. So we are left with root 27 over 9 or 1 over 9 root 27. And this should be the answer. So thank you. Do well to like this video. More videos will be coming soon. Thank you very much for this. If you have issues, go back to the first video we did under how to add, subtract, and multiply in Surds. Thank you.